If I have the chemical formula of a compound, let's say that we have the chemical formula of a compound like aluminum sulfate, SO4 3. So the way I would interpret this, if I want to use a chemical formula as a conversion factor, I will focus on what information this is providing me with the subscripts in the chemical formula. So the way I would interpret this is that I have 2 moles of aluminum, right, present in this chemical compound. So I have 2 moles of aluminum. I also have 3 moles of sulfate. And I can use that there is 2 moles of aluminum, and the ratio is that it is to 3 moles of sulfate. I could also use it for just the element itself. I could say that the ratio is 2 moles of aluminum atoms for every 3 moles of sulfur atoms, right? Or there is 2 moles of aluminum atoms for every 3 times 4, right? 12. Oh my goodness. For every 12 moles of oxygen. And I can use the chemical formula as a conversion factor. I can convert either one of these into conversion factors where I have the 2 moles of aluminum at the top and 3 moles of sulfate at the bottom, or I can have 3 moles of sulfate at the top and 2 moles of aluminum at the bottom, right? So I can use these and I can make conversion factors for every single one of these relationships and do calculations accordingly. So with that in mind, let's go ahead and focus more still into these carbon-based compounds, and we're going to determine the moles of hydrogen in each of the given samples. So I am given the moles of the compound. So I have, this is my given information. Goodness, I selected too much. So I have this guy. I'm going to resize it, just make it a little smaller. I'm going to focus on this guy alone. Get it out of my screen. There we go. So I have my 2 moles, right? And I need to, so this is the given information, and I need to find the moles of hydrogen that are present and of hydrogen atoms, right? And what I am going to do, so this is my step 1. In my step 2, I'm going to make the plan. So I start with moles of the compound C4H4H10, and I'm going to convert this into moles of hydrogen, right? And in order to do so, I am going to use a conversion factor. And in this conversion factor, as such, I'm going to take these moles of carbons, and we're going to change the color just to help us track what we're doing. So I'm going to take those moles of carbon and I am going to put them right at the bottom of my conversion factor, right? So I have my compound over there. And I'm going to have my moles of hydrogen at the top, right? So I take the moles of hydrogen at the top. Oh my goodness. So I'm going to take those moles of hydrogen at the top. It will be just faster if I write it. Moles of hydrogen, right? So I can take this conversion factor and I'm going to grab my given information. So I can solve now. I have 0.0885 moles of C4H10. And I know that for every 1 mole of my chemical compound, there are, so look at the chemical formula, right? And I'm going to say that I have 10 moles of hydrogen. Perfect. So this is 10 moles of hydrogen, right? So there is 10 moles moles of hydrogen. And then I can finish up my calculation, and this is going to tell me that at the end of this, I'm going to have those 0.885 moles of hydrogen.